Alright, as mentioned, we have several examples coming up. So first example says find the tangent line of the implicit function at that point, and then also state where the tangent line is horizontal. Okay, so remember, for a tangent line, right, we need to find the derivative, which is the same as y prime. And so what I need to do is take this function, so x cubed plus y cubed is equal to 6xy, and I need to apply the derivative with respect to x, and then I'll have to solve for dy dx. So if I do this and do implicit differentiation here, derivative of 3x would be 3x, or sorry, x cubed would be 3x squared. Similar for y cubed, but then remember, if I differentiate something that is not my independent variable, I need dy dx. And then on the right side, ooh, this is a product rule. That is fun. So this is my 1 and this is my 2, so I'm going to do 1, so 6x times the derivative of 2, so that'd be dy dx, and then plus y times derivative of 1, which is 6. Okay, and now again, I need to solve for dy dx, so I need these things on the same side, so let's rearrange. If I move the dy dx's to the left-hand side and factor, what am I left with? 3y cubed minus 6x is equal to 6y minus 3x squared, and then solving for dy dx, I would get 6y minus 3x squared over 3y cubed minus 6x. Okay, and certainly if you want to, you can reduce everything by a factor of 3. That's fine. Okay, and then what we need to do here is we are looking at a specific tangent line, right? So then at 3, 3, I'm going to say dy dx. I evaluated this already. We get -1. You'd put in 3 for x and y and see what you get out. So then my tangent line would be something like y minus 3 is equal to -1, and then x minus 3, and I would be done. Okay, with the first sentence, because then it says where is the tangent line horizontal, right? So I'm going to say for the tangent line horizontal, right, that would mean that the slope y prime is equal to 0, right? So then I just have to set that equal to the 6y minus 3x squared over 3y cubed minus 6x. And really the denominator doesn't do anything. That would be where the tangent line is vertical. But here I just look at the numerator. And so solving that, I get 3x squared is equal to 6y. And then if I divide, right, I would get y is equal to 1/2 x squared. Okay, so what do I do with that? Well, that's where then I have to take that and sub that into the original equation. So I'd have x cubed plus, and then 1/2 x squared, all cubed, and then is equal to 6x, and then 1/2 x squared. Okay, let's see, following the arithmetic through, I get x cubed plus 1/8 x to the 6th is equal to 3x cubed. Alright? Okay, moving things around and factoring, I'd be able to pull out an x cubed, and then I'd have 1/8 x cubed minus 2 is equal to 0. So then this gives me either x is equal to 0, in which case y is also equal to 0, right? So that's one place where the tangent line would be horizontal, okay? Or solving this, so I'd have to move the 2 over, multiply by 8, cube root it, so I'd have x is equal to the cube root of 16. And then when I do that, I end up with y being the cube root of 32, okay? So that would be another point. All right. So there we go. We found with the Theorem of Descartes where we found the tangent line at 3, 3, and then also where the tangent line is horizontal. Again, if you're looking where the tangent line is vertical, that would be the denominator, setting that equal to 0. Okay, next example. I want you to pause the video, try and find this derivative, and resume the video when you're ready to see the solution. And here you go. Okay, to start out, the big thing to remember is when you have 3x squared, y squared, that's a product rule, right? So you have to do 1 d2 plus 2 d1, yeah? Otherwise, again, whenever you differentiate y, then you need to include y prime or dy dx. I always use dy dx. If you want to write y prime, hey, great, same thing, okay? And otherwise, it's just a lot of algebra after that initial differentiation. So if you do the initial differentiation well and you do your algebra well, you're sitting good, okay? So that is all the examples I want to do in this video. We will have another video with a couple more examples, and then we'll move on to a slightly new topic.